Hello, everyone.
Hi, hello.
Hi. Okay. So I guess you can hear me. Okay, I will put the Q&A mode on. So if you have any question, please put them in the Q&A, and we will answer them at the end of the webinar. Hello, everyone. I see hello, but I didn't see that the confirmation that you can hear me. So I hope you can. Yes. Okay. That's great. Okay, so I think we will start our webinar. My name is Piotr Loga, and I'm from technical department from Menlo Electric. So who are we? We are the fastest growing EMEA distributor of PV components. Now we have PV modules, inverters, and also batteries. Our main market is Europe. As you can see, we have logistic hubs all across the continent, but we have a new division in South Africa, and we start to expand to Middle East as well. So we are growing every month. If you want to translate it into numbers, it's 100 megawatts of constant availability of solar panels. We are now in 31 markets, and we discover new markets as we speak. It's 1,000 orders completed every month and 8 logistics hubs, as you saw on the previous slide. So every month we ship about 50 megawatt of modules. So we have a lot of different producers in our portfolio, and today we will focus on FoxESS and their hybrid inverters and their energy storage products. Welcome, Piotr. Maybe you can tell us more about it.
Hi, hello. I would like to greet you wholeheartedly and welcome you to our today's discussion and training. My name is Piotr Halek, and I'm a technical engineer in FoxESS Polska. We are a general distributor of FoxESS branded inverters and batteries also. And today we would like to introduce our products to you. My agenda for today is short. I would like only take a moment to tell you who we are, what we do, from where we come, and what can we offer for you. So about FoxESS, we are a daughter company of Tsingshan Group. 80s as a steel producer. Right now, the Tsingshan Group is the largest stainless steel producer in the world. We got the largest mines of nickel, cadmium, and other minerals needed to manufacture our products. So we can manufacture our devices using our own mined minerals that are processed in our foundries, and the final product that we can offer is a very good quality because we can check the quality of every component inside this this device. But also this means that we are not a small player. Our mother company has more revenue than Coca-Cola or Adidas, so we are backed by a really good and large company. So we won't be a small player, a meteor on the market. We won't be here for a moment. We are here to stay. I think that you would also be pleased with our products and be pleased partnering us in endeavors. About our manufacturing, we have 4 manufacturing sites, 2 for our inverters, 2 for our batteries. Our batteries are also produced by a daughter company of Tingshan Group, by RAPT. This company was established to research and develop new battery technologies. So our batteries are made, designed as a new product, and made from the scratch with in mind. Our factories are located in Wenzhou, Shanghai, Wushan, and Wuxi. Those are really big automated plants. If you would like to see them, I have a few photos during the way. But that also gives us an opportunity for a large quantity manufacturing of our products. And we are a vital place to test and to check our products, give a feedback to our manufacturing engineers. So we are also still upgrading in real time our devices. We have a large R&D team, because FoxESS has been founded with development in mind. Our team of engineers haven't started in FoxESS, so we gathered all the people, all the good engineers that were available, put them together and asked them to design a best inverter on the market. That inverter was designed 2 years ago. So yeah, it's using the latest in the technology that can give us the technology edge to implement our devices on our market. Really, our R&D team is larger than our sales management. So yeah, we are a very technical company focused on research development of our products. As you can see, we are all around the world right now. The largest office we have right now, with the biggest sales and support, is located, of course, in Poland. But we are also in India, in Americas, both EMEA, Europe, Africa, and Australia also. So we are on every continent that gets sunshine. So let's talk about our main target for today, our target is manufacturing of hybrid inverters and battery system energy storage solutions. This market, like you see, is forecasted to be really blown away. We are expecting a really steady growth of our device manufacture and, of course, putting them on the market. As you can see, this market is growing really rapidly, and I believe that we've took this market early, so we can output devices to you, keep them updated, and keep them running in really good quantities. Let's talk a bit about our products. Our main solutions for today are, let's say, dual. The first solution is a retrofit. When you have a operating PV plant with a standard on-grid inverter, using our set, you can add an energy storage system in a capacity of your choosing, without even taking down the on-grid inverter. Our retrofits, our chargers, are being connected directly to the AC grid, so they don't need a direct connection or communication, nor power connection with the inverter. So our retrofits are working with every brand of inverter. No matter what you have inside, you just put our AC1 for one phase or AC3 for three phase, add batteries and BMS, a controller for charging those batteries, and you have a working energy storage solution that can add to your consumption of PV power, your auto consumption, because you can charge those batteries with a spare energy from PV system, and then when the PV system is offline, has been turned off or sun goes down, this energy storage solution can output power to your grid, to power your appliances, to power your loads, to power your building, no matter what you choose. This is a very convenient way of adding such storage system, and a added bonus is that you don't need to change your inverter nor your grid. You just need to connect this device to grid, and that's all. If we have a direct internet connection, we can then properly set this device, check how it's worked, and of course set it with user settings also. And my second proposition is a pure hybrid, full hybrid inverter. It's age 1 or age 3 model. This unit is a full hybrid inverter that you connect your PV array to, your batteries, and your grid. This unit can operate like a standard on-grid inverter, like a hybrid inverter, but it also can work like an off-grid, full off-grid inverter. You don't need to have grid even to operate such a system. So that's, I think, the future of our PV systems. But on-grid inverters are okay, but they have limitations. With this inverter, those limitations has been taken down. This unit comes in a variety of nominal powers from 5 to 12 kilowatts, can be like this charger connected in parallel, so you can up to 10 units. So you can build your system basing on that. That can be up to 120 kilowatts in the PV array in the generator. So you can do a small system for a small house in the mountains without a grid. You can do it like a standard inverter, powering the residential building or small commercial unit. Or you can build a full hybrid system for motor hotel industry appliances. This system can also work like a backup system for your grid, for your place. Because when there is a blackout and the grid is down, this unit in below 20 milliseconds will engage EPS, emergency power system, and will output energy for your loads, for your home, from the batteries. And if there is, of course, sun up, the sunshine will also be converted to energy for powering your system. So it's a very convenient, very mature product. This product has been designed with the heightening of water consumption to the max. The user energy usage profile, like you see here, has usually two such bumps. One is in the morning when you get up, make your coffee, wash with hot water that needs to be heated by electric heater. Then you go to work and you leave your building, your system, without energy consumption. And in this moment, the energy conversion is on its highest. So if you produce energy but don't use it, you lose that energy. You usually sell it to the grid with rates that aren't optimal. Let's call it that. With this system, you can store this spare energy produced when there is the most energy produced, and flatten those bumps. You can use your own power to power your TV set, your fridge. During the night, you make your coffee from the battery system, and then when the battery has been drained, the sun goes up, again charges batteries and prepares the system for a night, for a blackout, or a standard usage. So that in mind, the less we export to the grid, the better. But the main thing here is a zero import policy. Because if you properly set such system, you won't probably need a grid import for your system to work. The grid will be connected, will be ready, but won't be used. You won't pay for external energy because you have your own. Those hybrid inverters come in two flavors. one-phase systems and three-phase systems. You can compose such system to your needs. If you want to set a small building, a boat, or a camper, you will probably need a single-phase inverter in the lower nominal power ratings. But those power ratings are from 3 to 6 kilowatts per phase. It seems little, but if you think about a standard on-grid inverter, which has a 10 kilowatt nominal power, this inverter outputs 1/3 of its nominal power that it's producing right now on every phase. This is called symmetric energy output. Our hybrids do not need such functions. In our systems, we want to output energy asymmetrically. But I will tell more in a bit. But those inverters, on-grid inverters that have, for example, 10 kilowatts, output on phase 3.3 kilowatt in a given time. So those single-phase units can probably output more power per phase than three-phase units. Just keep that in mind. This is a H1 series inverter. It's a single-phase storage inverter, has 2 MPPTs, 2 individual trackers for PV array, battery connection, and of course grid connection and EPS output to output power when the grid is down. Every hour device, battery is not included, comes with the IP65 class of resilience. So it can be mounted outside, it can be mounted inside the building, it works silently, so you won't hear a buzzing or other noises from the unit. It's high performance for charging and discharging batteries. Yeah, it's about 95% efficient with the energy round trip. So from taking energy from the grid, from the PV inverter, charging batteries and discharging them to the grid has 95% efficiency. It's really nice, it's really high, and I believe it's one of the best on the market. With every hour device, you get also everything that you need to install such system. You are getting terminals to terminate PV system, battery system, griding, and EPS. You get your Wi-Fi stick for connecting the device to the net to be remotely accessible. And you get manuals, quick installs, manuals. Everything that you need is in the package. With one-phase hybrid, you are getting also a single current transformer for the unit to know if the energy is exported or imported to the grid. It's crucial to install it because the system works on the data obtained from that CT, that current transformer. And if you order H3 that has three-phase output, you don't get a current transformers for every phase. You just get a two-way chinned meter inside that package to provide those data that are crucial for the system operation. Here you can see technical specification of our H1 series, also AC1 chargers. You may think of a charger like a hybrid inverter without PV input. Those devices are similar in build, but they don't have PV input. They don't need PV input because they charge and discharge batteries into the grid directly. Wide operating nominal powers, they are 13.5 amperes rated, so you can also use newer high current modules. Every such unit, H1, every such unit comes with two independent trackers, one string per tracker. Those trackers are independent, working like two different inverters. So you can even use a different brand of PV modules if you have them, remembering to put one brand on one tracker, second brand on the second tracker. Those will operate as usual. No. Our devices work with high voltage batteries. So low voltage batteries like lead acid or similar systems won't start this unit. H1 needs 100 or above 100 volts on the battery input to properly start this system. So the batteries are connected in series. The voltage rises with each module. And this unit can operate between two batteries, two Myra batteries, and up to 7 battery modules. That's the upper limit of voltage that can be accepted within the unit. It can output its nominal power, but it also comes with a system to start some heavier equipment, heavier devices, and it can output up to 150% of nominal power within a time limit to help start those devices during an off-grid operation or during a blackout when the grid goes down and the devices needs to be reset, restarted, and need more power to start. As you can see, efficiency of this unit, its internal efficiency is above 97%. It's fine, it's good. It operates without getting warm, so it don't loses energy to heat. It operates quietly. It's a really nice device. And this is its bigger brother, it's H3. Generally, the logic behind that unit is the same as in one-phase units. The chassis is bigger, but also IP65 rated. It boasts its high performance and being easy upgraded. I will show you how easy it's to upgrade with ESS, or how easy it comes to add more batteries, more capacity to this energy storage system. The difference between the on-grid and the hybrid inverters can be seen also on the screen. Our on-grid inverters has only one button, only one touch button on the front panel. Here we have a convenient four buttons for navigating the inverter's menu and to check or set this unit accordingly. It comes also with a Wi-Fi stick for remote monitoring. And here we have some technical specification of those systems. Those units, as you can see, are also on one data sheet with the chargers. The main difference between hybrid and charger in that matter is only that charger goes up to 10 kilowatts per unit, and hybrid systems are more powerful. They can output up to 12 kilowatts, but there is a catch. We also have two trackers, but we have to diverse those trackers. They don't have identical parameters, so the input power for the hybrid inverter should be connected to two trackers without giving a max nominal power from the PV array for one of those trackers. Because as an example, if you have a 4 kilowatt unit and you add, for example, 6 kilowatts on the first tracker, this tracker will only go up to 4 kilowatts, and those 2 kilowatts won't be processed. So it's better to diverse them, 4 for the first tracker, and the second tracker will operate on those 2 kilowatts that we have left. Maximum input voltage is 1000 volts. Please remember that this is a maximum voltage for this system to operate. That doesn't mean that you have to build your PV array or your PV string with this 1000 volts in mind. Please keep your strings, your voltage on your tracker in the optimum for every inverter. And this optimum is about 600 to 650 volts. If you provide 700 volts for this unit, it would be perfect. It would be really a sweet spot, a optimum for this unit to operate. And it will start up with 4 PV modules also, but also please remember that this is a device start voltage, not operating voltage. It will start, it will show that it's working, it will operate with batteries, but 160 volts is a bit too small to operate with some sensible energy input and output. But if you have an opportunity to connect some newer shingle or bifacial modules, you can do that. Those units can input as much as 40 amperes per string. So I believe that all of our PV modules on the market will be accepted within this unit, excluding those special modules designed for other purposes. It operates also with high voltage batteries, and the battery amount for this three-phase system is a minimum of 4 Myra batteries, which translates to about 200 volts for the system, for the BMS. So the system needs a 200 volt on the battery input to properly connect to the BMS and start those batteries. Those units you are using RS485 communication or CAN communication. Generally, if you want to talk with this unit, you can use Modbus or any appliance that can output a Modbus translated message to the unit. Perhaps you have some smart grid or smart home device that operates your home energy management system, generally management system. You can easily add this inverter to output information about the system to your HAMS smart grid, smart home device. Of course, what is also important, and I don't see it on this chart, but as I said earlier, those units are capable of selecting, switching from the grid to EPS mode in under 20 milliseconds. It's a while too short to disconnect your electronic appliances. You will only see a blink of your lightning, of your LEDs will just blink for a moment, and everything will be powered from the battery. Of course, it's a full hybrid, and you can set everything from the reactive power, active power. You have a wide variety of settings that you can use to design this site for the client's needs. If you want, you can check those settings. We have manuals, instructions on our page, on our forum, so you will find it. And a few words about asymmetric power output, because that's really really important, really needed for the off-grid operation. This means that if you have three-phase unit, this three-phase unit won't work in asymmetric mode. You can turn it off, but it will turn your hybrid inverter from hybrid operation to on-grid operation, and you will do a downgrade for your system, to be honest. So with asymmetric power output, we can output a given amount of energy that is needed to power the end client's loads or end client appliances without putting the energy on other phases. So you can output as much energy as the client needs without exporting this energy to the grid or overpowering those phases that are blank, not working, or not being powered. This is really important for conserving the battery energy. Battery is used only and directly to power the end client appliances. So every watt of every joule of energy is being given to the client and not to the grid. That's really efficient and good for energy efficiency of such system. You can see on the screen, if we have a different loads on different phases, like here, this hybrid unit will provide power, but in an amount that is needed and not a lot more. So if this first phase needs 1 kilowatt of power, this 1 kilowatt of power will be given from the inverter. This inverter will push energy to the loads without using any grid to power those loads. On the second grid, we have 3 kilowatts, so we are giving 3 kilowatt for those appliances without using grid energy, without importing the energy from the grid. And this third phase, let's call it cold, without any appliance being turned on. So we are not giving any energy for this phase. And as you can see here, a standard on-grid inverter, it's producing 6 kilowatts of power right now, and it's outputting symmetrically 2 kilowatts per phase, no matter how much the client needs. This equipment is designed to produce energy for the grid. The client is on the second place because it's being powered with its own energy, but it may not be powered in such a way that is convenient for him, like here, because on the first phase we are exporting the power, but again comes on for the loads on the second phase, and the third phase is only exporting the energy to the grid. It's working, it's fine, but it's not efficient and it's not for off-grid or hybrid operation.
Okay, maybe here I can have a question about this slide.
Sure.
Because as we can see, there are different loads, and let's say two of the loads of the phases are 0 kilowatts, are taking 0 kilowatts. What's the maximum output that you can give on a single phase?
Usually it's a 1/3 of nominal power. So if we have on this example a 10 kilowatt unit, in standard operation, we can output up to 3.6 kilowatts per phase. This is the limit for inverters in general. And I believe we may output this energy. If we have such energy, 10 kilowatts, we can output a 3.6 kilowatts per every phase, or output no energy for the phases. So you have from 0 to 3060 watts per phase.
Okay. Thanks.
Okay. I would like to show you a very maybe confusing diagram because this whole system is shown here. but it's very convenient for me to show you how the connections are done and how this system operates. You have your grid connection going directly to the Chint meter. We have a three-phase hybrid, so this Chint shown here will be with the inverter. And you need to mount it, install it directly after the operator meter or operator safety fuses. The grid then goes to the grid AC in the inverter port. But as you can see, we have another grid cable coming to the EPS box. EPS box is a automated transfer switch. If there is a blackout and there is no energy in the grid, this inverter will start to output this energy on emergency power output this energy to the local grid. And if you don't have a switch that disconnects this system from generally the distributor's grid, there is a risk of electrical shock for the technician working on that blacked out line, because if you output energy to your local grid, this energy will flow to the distributor's grid also. And if there is no hole in this system, no disconnection within this line, this power goes then to the transformer that transforms it to high voltages and send it back. So there's a risk of killing someone. This is required by law, and every blackout that will come, and if you have this unit, you will hear a click, and that means that you are disconnected from the grid and keeping guys working on those lines safe. It's also a FoxESS product, but you may use your own way to disconnect from the grid. I don't push you for using this system. If you have something that is prettier, better working, use it. But connections. This grid goes to the EPS and then to the end client's loads, to the end client appliances, his fridge, his TV set, else. But this EPS box also have a EPS port that comes from the inverter EPS terminal and goes to the EPS box. I will show you in a moment, but operation is really easy. It switches the power from the grid to the EPS to power those loads and disconnect from the grid at the same time. Operation is pretty easy. It's a really convenient unit to just put on a wall and connect to it. You also have, of course, battery connections on the inverter. That battery terminals provide power taken from exported to BMS. BMS is the first black unit you see with the Myra name on it. This is a battery management system. It is used for charging, discharging the battery cells, controlling battery cells, controlling the temperature of the set, voltage levels of each and every cell in this system. And this BMS also controls the charging current given to the batteries, keeping the batteries safe and healthy. That's the main function of that device. And below you can see 4 battery units. Those are Myra HV25 batteries. Every battery, every module have a capacity of about 2.5 kilowatt hours. So you have your minimal set for a H3 inverter. In a standard, you get 10 kilowatt hours because you need 4 batteries to operate the system. So you're getting your 10 kilowatts as a default for 3-phase hybrids. For 1-phase hybrids, as a default, you are getting about 5 kilowatt hours. And here we have a operation, a scheme of that inverter that connects to the PV modules, connects to the batteries, and if PV modules have power, this power is then directed to the inverter and proceed as the client wants. You have 3 main priorities. You have priority for self-use of energy. You have priority for selling energy. If you can sell your excess energy for a good price, yeah, you can do that. And the third priority is a battery priority. It's called backup, and this mode keeps the battery topped up for in a case of a blackout or some disturbance in the grid. And this AC grid, local AC grid, powers the end customers' loads. And in this, let's for example say that this unit works on default with this self-use mode. Then, if you have PV modules powered, if you have your inverter powered up, and your battery is empty, this energy from PV modules will firstly provide power for the end customer's loads, and if there is excess power, this power will charge batteries. And if you have PV power from PV and your battery is full, you will provide energy for the end user and then export this energy, this excess volume to the grid to power your neighbor or else. The most important hybrid features are that they are really high powered. They can operate in a full off-grid mode. They have integrated grid disconnector. So as you've seen this EPS box as an external device, H3 and H1 comes with this EPS box built in the unit. So you don't have to use external EPS unit to power the client. If you have perhaps more than one hybrid, then this EPS will be highly in demand because that unit you've seen has a 32 amperes maximum current. So two 10 kilowatt units working in parallel are the max that can be redirected to the client using this EPS box. We have some larger EPS. I will talk about them later. But if you want, if you have some simple installation, you can connect grid directly to the inverter, get your power directly from the EPS, and give it to the client grid, to the consumer unit. And if you do such a thing, you are using this integrated disconnector, and when the blackout will strike, this grid terminal will be isolated, galvanically isolated, and this EPS output will still provide power without even interrupting the power flow. It will only disconnect from the grid. You won't notice because of the UPS switching time. Those units can work in parallel, like this. Here you can add 9 more units. 10 is a maximum stack for H3 and H1 and AC units. But still, you can operate a system, hybrid system, up to 120 kilowatts in PV generator, and using Myra batteries with those inverters, you can build a energy storage capable of holding 200 kilowatt hours. So there's enough power to really operate with the sites or bigger buildings. I would like to tell you, of course, that but there's a limit of what you can do with it, EPS. That's its nominal power. That's logical. You can't output more power than this inverter is designed. It's nominal power. Also, client needs to know that during the emergency operation, this system and the client's grid operate as an emergency system. That's not the right time to power your very heavy loads, because you may just overpower the unit. Another thing is that this EPS is centered on the inverter. The inverter is the energy generator for the whole system. So if you have some appliances that use a half-bridge rectifier, we have 2 types of rectifiers: full bridge rectifier and a half bridge rectifier. Full bridge rectifier rectifies AC to DC and creating a straight line and taking all the energy from this AC unit to process it to the DC current. If you have a half bridge, you take only half of the AC sine wave. you get only plus or minus from that sine wave. This this operation takes only half of the charge from the inverter buses, from the inverter positive and negative bus. That will end this inverter saying that it's overloaded, because there is not enough power taken. We are taking only minuses or only pluses from the inverter. If we leave those second charge on the inverter will stop working because of this imbalance. Half-bridged appliances are not to be used in emergency power systems. And I believe that no manufacturer have come with a solution for that issue. We are working on it. We'll try our best to mitigate it, but it's important that you know that those systems have very high potential, but also, like every device, there are limitations in operation. Installation of such a hybrid system is really very similar for like connecting on-grid inverter. The only thing that is added is EPS output that needs to be connected to output power in emergency situations, but you don't even have to use it. If you plan to operate it with grid up, you really don't need to populate this EPS terminal. You only need a AC grid connection, and it will automatically take energy or output energy to that grid for the client. As you can see on this diagram, maybe it's not so visible, but this unit have a very hefty heatsink. It can output a lot of power, and it can output a lot of heat that is produced in that situation. We have separated our coils, from the part that cooled our transistors. We added a mechanical ventilation, so we have a fan. If there is too hot, the fan will start and cool the device. So there is rather no possibility of overheating this unit. The only thing that can be added, this unit is heavier than your standard on-grid inverter, probably by 10 kilos. So if you can, please do it with your colleague, because it may be difficult to put it on the wall by yourself. I've made it, but yeah, it was a pain. So it's best to have another person on site to help you with the installment of that unit. As you can see, we have two trackers accepting 3 strings. Those 2 first strings are paralleled to use in the first tracker, and the second tracker have PV3 as an individual power input. Of course, we have parallel connection to connect to a neighboring unit. We have a USB for updating the firmware or connecting to the internet via Wi-Fi stick or Ethernet stick. Client chooses his medium. Communication terminal is multi accepts meter. It accepts a RS485 communication with a server, perhaps. It accepts also a connector for the EPS box to properly steer the work of that device. That's, I think, all that can be told about this unit chassis. It looks nice. It's designed, last year, so the design is fresh. I think that looking at it, it's also a good device. It looks good. And it works good.
Okay, so maybe before we go to the next section, I have two quick questions. So the first one is, as it's hybrid inverter, it can, if we don't have batteries for it, we can install it as an on-grid inverter, right? But my question is also, if we never want to connect it to the grid, if it can work as off-grid inverter only. Is that possible?
Sure. Without any time limits. Those units are ready to be used as an off-grid inverter, no matter the place, no matter the time. So yeah, you can use it both with or without batteries. Without batteries, of course, it will only output power from the PV array to the grid. And if you have batteries, it will also charge the batteries.
Okay.
Power you when the sun is down.
Okay, I have another question because I saw that it can be the battery can be charged from the grid, right? When there's no PV power.
Yeah.
So my question is, let's say there's a power outage and the battery is full. It starts to power the loads, but we used all the energy that was stocked in the batteries, and the inverter shut down, right? But let's say the power outage lasts one day, and after the night we have the sun and we have the power from the sun, and we want to power our backup loads. So do we need a minimum of the state of charge that we always need to set for the inverter to start from the energy from sun and solar energy, or is it possible?
Yeah, sure. It's possible. It's a standard operation for that unit. It's designed for doing that. So, concerning the state of charge needed for the battery to, let's say, live and don't die, don't decompose the chemistry inside, the BMS will always check and provide enough charge in the cells automatically. So the minimal charge amount the battery is 5%. You can choose your own minimal state of charge for those batteries, of course, But if you don't have perhaps steering possibilities to turn the power off and the batteries go down, it will always have some charge in it for the next day to be powered and to keep the health of the cells and the battery and the system as a whole in good condition. So the BMS will always work and always check and provide a good amount of charge for the batteries. As for the second part, you can charge those batteries from the grid, but in general, this system has been designed in, off-grid in mind or hybrid in mind. So this system automatically won't charge the battery from the grid. It strongly advises the zero import policy. But if you have perhaps some cheaper tariff, cheaper rate for energy in the night, you have a possibility to choose two intervals, time intervals, when the battery will be charged from the grid. It will always come with this red LED flashing because it's an anomaly for that inverter to take energy from the grid. But it's possible, it works, and those batteries can be charged with cheaper energy, and the energy can be used during the higher rates. So that comes with efficiency, in natural.
Okay, good. So thank you. I think we can go to the next part then.
Sure. I would like to talk about batteries because in FoxESS I mainly operate with batteries and everything with batteries, so chargers, hybrids, BMSs, batteries itself. We in our system use lithium-ion batteries. And speaking of lithium-ion, everyone thought about fire, explosions, and mishaps that happens. Well, lithium-ion is a family of batteries. It's not a one type of battery. Let's talk some more about lithium ferrite phosphate batteries, because this is the technology of our choice to provide it for home energy storage. Lithium ferrite phosphate batteries first are safe. They don't spontaneously combust. They don't explode. They don't degas. They can be charged and discharged with anomalous amounts of current. Their life is really long. Chemistry is really resilient to changes. Batteries weigh less than lead acid batteries, of course, but that don't mean that those modules are light. Every such module weighs about 30 kilograms of cells. It's full to the brim with cells. So about those weight, you may be expecting less, but that second person on site will come in handy. This chemistry is best suited for PV systems because we can input and output energy from that cell without it getting warm. It's very low resistance. internal resistance. So when you charge or discharge those batteries, they are not getting warm. They are getting warmer. I've tried 4 full nominal power charge and discharge cycles and checked the chassis temperature. It was about 32 to 34 degrees Celsius. So yeah, they just work. They don't heat up. They are stable. Of course, if you those terminals or perhaps short the terminals of the whole stack, that may cause fire because there is a very, very large amount of energy stored in the system and can be outputted in an instant. So the cables may burst in this case, but those batteries will live. The chemistry won't be changed. They will output a very large amount of energy instantly, but they are designed to do that every day. So yeah, I really don't have any replacements for those batteries because they just work. This chemistry, earlier I've talked about this lithium-ion battery family. You may also think about lithium batteries that use lithium in a metallic form. There is a lithium foil in this battery. So lithium is a very reactive metal. If you open this battery, humidity from the air can start to react with this lithium to produce a large amount of heat, gas. It can burst in flames, and if you throw it into water, it can explode. Our batteries don't have lithium in a metallic form. We have only ions. It's like dissolved sugar. It's not its in original form, it's crystallic form, but dissolved into a layer of electrolyte. So you don't have this lithium fire risk with those batteries. But LFP is on the market not from yesterday. It's working technology years now, so it's pretty stable technology, and we can warranty the product because we had made it from the scratch, from digging the minerals from the earth, from dirt to this product, and checked what happened with this device on every stage of manufacture. So let's talk about battery and battery system and battery stacks and where to put those batteries, how to connect them, what they can offer. This is a HV25 Myra battery. It's a standard modular battery. This module can be placed in a 19-inch cabinet. We have some cabinets manufactured by other partners, but I'm pretty sure that if you have any 19-inch rack cabinet, teletechnical power cabinet, you can place those batteries there. They are about 2U of size. So for a working system, you will probably need 10 or 12U of that cabinet. So this is a modular unit, and if you want to add some more units, you just shuffle them there, connect them into that stack, integrate them, and probably after some 10 cycles of formatting those new batteries by the BMS, it will be integrated into that stack and working perfectly within this stack. This unit can output very large amounts of energy. It's high performer. It's really resistant to chemistry changes. As you can see, we can warranty up to 6,000 cycles of such a stack. It's easily scalable. You just need to put another module, connect it, and to turn a dip switch on a BMS that the new battery has been added. It's high voltage, so we'll connect them in a stack in series. Remote monitoring is, of course, provided by the inverter. And the inverter aggregates informations from every connected device and sends it to the monitoring platform for end user to see how the system performs, or for technical support for installer to check if there is any fault mishap on the side. Every such module holds about 2.5 kilowatt hours. It's rather 4.96 kilowatts of kilowatt hours of usable power, because you have to have this 5% limit for the SOC for the batteries to keep them in good health. Here you can see a minimal stack of 2 Myra batteries with 1 Myra BMS. This stack outputs 100 volts and can hold up to 5 kilowatt hours of energy. It can also output a bit more if it's needed, but of course within this 30-second time limit. Here you go. There is a writer's mistake. Here, those 4,000 cycles should be 6,000 cycles, and that's only this. Sorry for that. What's important when thinking about such battery system is that this unit has only IP21, 22. It's not resilient, not resistant to water or humidity above 100% when it condensates. It's strongly recommended to mount it inside a cabinet, and the cabinet, of course, should be inside the building, because the more stable parameters we have, the more stable work we'll get. If the temperature is too low, BMS will automatically restrict nominal power that can be input or output from the battery system. So the BMS always keeps his guard and will take care of batteries, but those batteries in below zero temperatures will probably not work as in nominal data sheet because of the chemistry. use LFP chemistry that is best suited for room temperatures. It's really important to keep them below 50 degrees Celsius, also because of the battery chemistry. If we go above 55 degrees Celsius, we will kill the battery. The chemistry will go wild, and this will be permanent. If we have a battery that operates in lower temperatures, when the battery heats up, it will go to its nominal parameters without any problems. If we overheat this battery, perhaps by mounting it in such a way that the sun can operate, the sun can warm this unit up above, or the cabinet above 55%, we will get permanent chemistry damage. The cell will have anomalous parameters and will not keep nominal parameters over such overheat. We need to store them best in the room temperature from 15 to perhaps 25. It's the best. But if they are in a cabinet, the cabinet can be with convection cooling. They are not getting warm by themselves. They are getting warm when the sun shines on them, when there is a heater nearby, to check the environment in this temperature way, and to place those batteries there where there is the most stable temperature, humidity conditions. So it's best used indoors, in some cases that have higher IP rating than the batteries. It's not really recommended to place them without any cabinet or mounting brackets, because they have connections on the front panel. If you have kids, if you have pets or animals, there is a risk of disconnecting some connectors, risk of tampering with this equipment. Just close the cabinet, lock it, and everything will be fine. Those batteries will be fine. BMS will always check and always keep them in good health. Here you have minimal, maximal stack for those batteries. Those empty places are that stack will not work. H1 or AC1 one-phase system will not operate with above 400 volts. Three-phase system will operate with such voltage, but it needs more voltage for a start to properly operate. As you can see, the battery isn't complicated. You have two terminals, two energy, two power outputs. You have two communication terminals and two LEDs. Red is good. Green is good. Red is bad. Those deep switches are for some older BMSs. We use BMSs with automated address placement, so you don't need to change anything on the battery. You just put it in a rack, screw the earth terminal, connect the power terminals, connect the communication cables, and you are done. So it's pretty easy. It's also pretty easy to set up a BMS. As you can see, we have 4 power terminals, 2 for the batteries and 2 for the charger or inverter to take the power and convert it to the grid. Safety switch, we have power switch, we have B-start switch. B-start is a black start. It's a switch that you use to turn on the inverter, because you may not want to turn this battery system automatically, so you don't push this B-start button. I strongly recommend to push it, because BMS is a really finely automated safety measure. It's best to be active. It's best to be checking what's happening with batteries, with inverter. It's best to be just used. You have a handful of LEDs on the BMS. You have 2 LEDs like in the batteries, green, good, red, bad, some alert or error, and you have 4 state of charge LEDs, and every LED is circa 25% of state of charge of the system, of all the batteries in the system. This arrow on the dip switch tells the BMS how many modules we connected. So the minimal amount on which BMS operates, it's 2 batteries for H1 systems. So this is a default position of this dip switch. 0 on a dip switch means that we connected 2 batteries. If we connect 3 batteries, we select 1 on this switch. And what if we have 6 batteries? Let's check. It's 4. This is really important to set, because if we have different amount of batteries than we selected on a dip switch, the BMS will not provide power to the inverter. It will power up, goes into fault mode, and will start beeping. So yeah, it's important to set, and it's really simple, because this set is a amount of battery connected to the system minus 2, and you will get your dip position this way. And after selecting the proper position, the BMS will start, and this green LED will go fully lit. We have 2 communication terminals, 1 for the inverter, 1 for the first battery in the stack. Those connectors are RJ45. It's a standard Ethernet cable, so you can also provide your own cables if those provided with those devices will be too short, because of course we provide power cables for the inverter and the BMS, and also battery connections. Battery cables are also in the set. We have also added communication cables for every battery to be ready to be connected to the stack. And also earth cabling is also in the packet. to properly and quickly ground those batteries. Those 4 state of charge LEDs will be a fine diagnostic tool if there is some problems with this system or with the BMS. It will blink those LEDs according to the fault occurred. So sorry for that Polish chart, but if you order such a BMS, you will get part in the BMS manual in your language. This is only to show how it works. Like if you have modules that have different voltages that can't be properly integrated into the stack, the BMS will go red here and blink the last of SOC diodes. If you disconnect your communication cables, BMS will go into fault mode, into alert, and will blink all those LEDs. It's a good way to diagnose problems and a quick way to check what's happening with the equipment. Our LFP batteries have, I believe in the Myra we have 32 cells connected. Every cell is being checked for temperature, for voltage, and for health. As you can see on this chart, there is really, let's say, rather small difference between fully charged batteries and a half-charged batteries. It's only a volt. BMS is always keeping those measurements and the state of charge that the client sees in the application or on the inverter screen is always a virtual information, virtual data calculated using cell historical and now voltage, its temperature of all the other components, and the state of the BMS. So the state of charge isn't some measured volume, it's a virtual thing. It's a product of an algorithm. We are still upgrading that algorithm. This LFP SOC measurement and calculations are really difficult. So there are few manufacturers that can make some really good BMSs with those algorithms. Our algorithm works okay right now. It works fine. It shows the proper values, but still we are working on every improving this logical component also. So the BMS is not a device that will operate and it will operate indefinitely on its firmware. Probably your inverter will be updated for your convenience, or you may also check if the inverter is up to date and working properly. We can also also send firmware for the BMS and for the connected batteries. So we can have an eye on every device in the system connected to the inverter and the net. Battery modules. Here you can see how those battery modules look inside. But generally, those are two rows of cells connected to the power output, directed by the board. Well, not seen here, but we've seen terminals, connectors connected to this board. This board have communication with the BMS, and it's for logic operation, local measurements, local safety measures. This is also checked per battery. Every battery has its own processor to operate. And as I've said earlier, all those components are sourced by us. Try to use as many our components and get them higher in quality. As you can probably think, if we do everything ourselves, this is the reason why we can offer good quality in such a nice cheap price. But that vertical integration of the quality, vertical chain of manufacture is really great for giving end customer the most high quality products that we may offer, and that is warranted by this 10-year warranty also. Here you can check our partners manufactured cabinet for those Myra batteries. This cabinet holds 4 battery modules and 1 BMS for those batteries, conveniently within one enclosed cabinet. Can be locked. It's a really simple product. It's a really convenient product, cheap product, but this cabinet, it's not the only product that has been designed. Right now, many of our partners start to design and manufacture such units, such cabinets. So it's really nice to put the batteries in the cabinets. It also looks nice. It's nice from technical perspective and safety perspective also. But you don't need, again, to buy this particular product, this particular device, because there is a bunch of other accessories that you may source for this system. We have, I believe, right now 3 producers of cabinets really for our batteries. So if you want some of that product, you will probably get them without any problems. And speaking about accessories, I would like to give you a closer look on this EPS box, because sometimes this internal EPS will be not enough or the client will have some other design features. This unit is a really simple device. It has 3 terminals. It is hermetically sealed. It's up to 32 amperes. So if you have one unit, one hybrid unit, it's really quick and convenient to connect this hybrid unit via this EPS box to the client cabinet and provide power no matter if the grid is up or not. It is automated. It is without any communication. It is steered by the sheer power, by the voltage. If the voltage dissipates on the grid, the EPS goes up, and this unit will switch input from grid to EPS and disconnect from the grid, making an island that is powered by the batteries of EV with batteries by this inverter. It looks like this. Again, this is a simple product. We manufacture it for your convenience, but you can make it yourself without any problems. You just need some components and connect them in the right way. We provide diagrams, schematics for that device. If you're interested, feel free to browse them on our FoxESS forum. You may also use them to build your own EPS, because sometimes the customer is not so fond of like a big box mounted on a wall when he have place for this EPS or just have place in his power cabinet in his customer unit. So you may buy some components, mount it within the cabinet, connect them in the right way, and you're good to go. But this is a unit that can output or has 32 amperes of resistance. If you have more than 2 units, if you have to have more power, this is the product that we are testing right now. It's not on the market yet. It's a new product really designed again for us. It's a bigger brother of that EPS box. It's an EPS 3-phase 4-unit version. It can input, output more power. It can connect to 4 inverters and provide power from that 4 units. If you have more than that, just use another unit and you are good to go. It's really convenient, and this should be on the market soon. Again, let's just check how the system works, because if we have grid operational and up, and if we have enough power for the client, for the customer, everything is good. We are providing power for the loads. We are pushing out this power from the grid to output it to the client loads. But let's say that night comes and there is no power from the PV to power the system. The power goes from the grid via the EPS box to the client loads. And if there is a blackout, there is only such a difference that grid is being disconnected and the EPS power line goes up to power the client in the emergency situations. This is to show how this hybrid is being connected. To be honest, is the best, I think, the best schematic, because there is everything you should know. Everything is connected nice. There you have your EPS box. This is a bridge between N line and the ground line. And this is added because you may have DNC or DNS type of grid. You may use it to bridge those two lines together, depending on the type of grid that you operate. You may use it on every TNS and TNC or so. Okay.
Okay, maybe before we jump to the next session, just one quick question, because I saw that the hybrid H3 has ATS built inside. So the question is, do we always need to use the EPS box, or sometimes if the loads are, let's say, don't need that much power and current, maybe we can just connect it directly to the hybrid inverter?
Yeah, we may, because it's really convenient. We don't need to place another cable and another device. And if we have some perhaps lower powered buildings or sites, you may completely omit this EPS box and put the power through the inverter and through the EPS terminal to power the client's loads.
Okay.
Yeah, the EPS, it's not needed for the operation, because we have this EPS box built in, and we can also use it.
Okay, so it's convenient but not necessary. That's it.
It's convenient, it's not necessary, and this is again for this device to be more convenient, because you may also set this device if we have internal or external EPS, and it can control those modes. It can output power in this mode that you selected also.
Okay, so we can go next, I think.
Sure. So let's talk about those power priorities, because every hybrid inverter, every charger operates its own program. In the firmware, you have three main modes of operation, and those are self-use, feed-in, and backup. Self-use is used when there is a focus for auto-consumption of energy. Firstly, in this mode, the loads will be powered. In every mode, loads will be powered first because of the power flow of physics. The client will always get his energy first. So in self-use mode, we are putting the focus on the energy stored for the client for the later use. So we are providing power for the client, and if we have more than the client needs, it goes to battery. It charges into the battery. Battery is full, well, the energy will then be exported to the grid for someone else to use. But we will have this battery full and ready if we come to our home in the evening, want to watch some TV, cook some dinner. This can be done with this stored energy during the day. And of course, the less focused is the grid, because the grid is prioritized only in the feed-in mode. In a feed-in mode, this unit can output power for the client, of course, but then we can set the volume, the amount of power we want to sell to the grid, perhaps 1 kilowatt. And we are harvesting 3 kilowatts from the PV array. Client takes 1 kilowatt for himself, and we have 2 kilowatts left. And if we set this mode to be 500 watts, this unit will send 500 watts to the grid. It will sell this energy first. And if this volume, this 500 watts, has been met, all the excess, in our case, 1.5 kilo, will go to charge the battery. And if the battery is full, the whole volume of energy is pushed to the grid, is then sold to the distributor. This is, well, good for some clients, having some contracts with their distributors. If they have some really nice rates, it can be set that way to sell energy. In the backup mode, the unit will be like a prepper. It will prepare itself for a blackout. It will charge battery to a given limit, to a given SOC, and will try always to have some set energy to be provided during the blackout. You have two minimal SOC. One is general SOC, and one setting is a minimal SOC on grid. And having those two settings, we can set minimal SOC for the whole set of batteries, perhaps, for example, 10%, and SOC on grid, we can set as 60%. And this battery, during on-grid operation, if the grid is available, it will always hold 60% of SOC of that battery as a minimal amount. It will operate, of course, with PV harvesting energy and charging energy to the battery, but we will have only 40% of the nominal capacity of that battery for the end client to use in the usual way to help his auto consumption. But this 60% of SOC on grid will limit the amount of default power for the PV system. But if there is a blackout during this backup mode, we will have, in our example, if we set 60% minimal SOC on grid and the absolute SOC on will be at 10%, we will have 50% of the nominal capacity to be discharged during this blackout when there is no grid connected. That will enable this bank to output energy, to output its reserves, and if the grid goes up, then this is a one of a case when the unit will charge the battery from both sides. It will charge the battery with the PV power if it's available, if it's possible, but also the grid will be used to charge the battery with maximal nominal power of that unit, of that hybrid or of that AC charger. This is to prepare the battery, to charge the battery to those 60% as fast as the unit can, because we don't know if another blackout will come in a minute, 10 minutes, 2 days, or never. So this is a mechanism for people that want to have some reserve, or that they have unstable grid conditions. Maybe some mountainous terrain when the power lines go through the forest and is affected by the wind, by the windfalls and other such instances. Okay, as I've said, monitoring and connecting this unit to the internet is really important for us. It's really important because we can check then what's happening on site. We may check everything from grid voltage, PV voltage, currents, current operating power, where the power goes, how much power is given or taken on every phase. We may check temperatures of everything. Inverter itself measures temperature, I believe, in 4 places, 3 or 4 places. The same for BMS, and the batteries have every cell with a measurement of temperature, and there is a measurement of the general temperature in the unit. So we may check generally everything what's happening on site using this inverter to show it to us. So it is a really good place and good device for diagnosing really some quick repairs or quick add-ons or configuration changes. Every our device is compatible with our one FoxESS cloud platform. We have one platform, but our device can be shown there. You can monitor our devices from anywhere from the world, because it's online. Our servers are located in Germany, so it should work best no matter where you are on the world, because Frankfurt is a really communicated collocation place. You can check your current data, your historic data. You can adjust the battery SOC, minimal, maximal. You can change your device work mode. You can change your device settings. You can make every change that you can change locally on an inverter and more. There are more options there, on the cloud that in the inverter menu. It's because, of course, of the end client sometimes too eager to change something. It's better for installer to have this opportunity to change something remotely or check something remotely when he got a call from a client stating that something is wrong or not working as it should. This is a screen of our this is our application for mobile phone. Those are 4 screens that every user sees when he installs it and is asked to sign up to the FoxESS cloud. Signing up to FoxESS cloud is not moderated. You get your access automatically. You just need to enter your username, password, and email. But email is not for communication purposes or marketing purposes. We will never send you an email. This mail or this phone that you give in this application is only used during the password reset. When you click that you forgot your password, a validation link will be sent on to your mailbox, or via SMS. You will get your validation code, and you can check it on your phone. The next thing that user or installer or agent selects his user type. And for end user, you always pick end user. This permission set, this account limits FoxESS Cloud to showing the data and make simple changes like work mode changes or SOC changes, because end user is not able to change his power settings or his power standard. This is required by law, and this is about it. So if you get your client an account, you pick end user. But if you are an installer, pick installer, because this account allows to make changes within the inverter settings. And this is the thing that we want, to make remote changes to firmware or settings of that device. Agent has the same permissions set as installer, but he is able to aggregate installers. This is a level of clarity that you have your perhaps corporation or large company that sends some installers. Some may be independent, some may be employed by them. they have many installers aggregated on this account and are seeing every site, every inverter, the installer that is connected installed, and the installer can check all the installations he done, and the end user. Installer can aggregate end users, and agent aggregates installers. It's easier sometimes to check a list of sites and check if we have some faults or some mishaps there. And you just, like I've said, there is no moderation on this site. You just need to write down your name, your code will be given to you in the registration process, and you can fill in contact phone. As I've said, this is only used for password management. It will not be used for sending spam or coming to you by anyone. We don't use it. And this is the application that client or installer sees. You are greeted by this overview window where you can simply and quickly check how many installations you have, how many installations are working right now, how many are not working because of some fault, and how many of them are right now offline. So we don't know if they are really powered down or there is some problem with the internet connection. And you can simply check today's yield, today's power ratings. After picking sites, you can check a list of your sites. You may have more than one, of course. If you are an installer, you will probably have a list of those sites here. Clicking on this button in the upper right corner of this box, you can edit the site. You can change every information generally about the site, because those informations again are not used to identify you and send you spam. This is only to show proper values in this overview window and to show the proper place on the map. It's also connected with the language, with the currency, and who was the installer. After connecting a data logger by simply clicking this icon, scanning the QR code that is on the data logger, you add this data logger, save those data, and then you will have your site overview. Here you can see the power graph. This is power in time, but you can also check every other parameter of that device. You can check other devices, because you may have a site, a power plant that is made of 3, 9 inverters. That's up to you. So you may also have other devices there that you want to check. or you can just want to check the error log of that unit, and this will show you every historical error that the unit supposedly came onto. This is the view of that inverter when you click device and select an inverter, you will be greeted by this inverter details. So your plant, your site will provide data about aggregated total yield of every inverter in the system. And if you click your inverter, it will inform you about its individual local settings or performance. Here you can see that 0.2 kilowatt hours had been produced. I believe it's been only turned off for a while. If you go to real-time data tab here, you will get a graphical representation of the energy flow. You will know if the battery is discharged or charged. This button will go up or down. You will know how much the customer loads connected to the system take. You can see your other inverter, because this may be your charger and this may be your inverter. And this is grid on which we can import energy or export energy, represented in this power dissipation graph. But from this graph, we know that 2 kilowatts are being taken from battery, discharged from battery, converted to AC, and then put to the customer's loads. Clicking on the battery tab, you will have some quick info about the battery. Like here, we see that the battery is working. We see SOC of the battery, graphical representation of that SOC, power voltage, and current ratings for the system right now. If you click this button, you may choose the right minimum, maximum SOC, and the rest of this battery settings. And if you click this real-time data, you will get a information packet sent directly from the inverter, and this is an info packet, telemetry data, that the inverter sends. It's presented only translated from Modbus to something human can work on and given to you. So this is most basic info on which every algorithm working inside this device works. But you may also use FoxESScloud.com. This is the same monitoring server. This is the same platform. No changes. The location is the same. The machine is the same, but we are accessing it via web browser. Like a standard website, you can log in using your account from FoxESS application. You just put your login into the website and password into the password box, click OK, and see such a page on which we have the same information that we got from mobile app, but presented in somewhat more convenient way to provide diagnostics or to check many of the devices, because we may see the inverter status like everything on in a one window. We have battery status automatically appearing in the right corner. We are getting this earlier power dissipation graph here a bit more in a horizontal way than in a vertical way. And we have our graphs. Here we can provide graphs from every sensor. So we may choose to visualize power, voltage, current, temperature, loads, frequency, everything you really need can be checked on this page. And also on this page, if you have a inverter and the inverter is online, we may access remote settings and change everything on which the inverter operates. From system time, basic parameters, work modes, and I believe every option can be changed here. So let's check because basic parameters are the most important to properly set the unit first time to engage and not to do a mishap there. You must properly set the grid code for your local grid for the country on which you install the device, change the language accordingly. Right now, I believe English is the most used on those devices, but of course we may do a translation in any other language provided also, so this is not a problem. Every unit comes with its own measurement, let's call it measurement system, because one phase comes with current transformers, and three-phase system comes with shrink meter. So here you can enable this shrink meter, or maybe perhaps you have a CT lying around. You may also add a second CT for the inverter. If you have a charger, one will inform about the input and output, export and import energy from the grid, and the second one will provide data about what's happening on the phase on which the inverter is operating, how much power he is providing for that phase. A DRM state is demand response module. This will be, I believe, more and more used. It is used by the energy grid operators to remotely reduce production of PV systems. If there is a really high solar overload happening somewhere, the operator wants to have some possibility to lower the production. remotely by giving a signal from one centralized point to every inverter there. So this is for turning on and off this function. You can also change Modbus address. It will be more convenient for those hands systems or smart home centrals. They will probably talk in Modbus, but they will also need to know on which address this inverter operates. You may change password here. You may change also your EPS output because you can set this EPS as you wish. This EPS don't need to be 230 volts. It can be used as a source for 110 voltage with 60 hertz clock. So yeah, you can do your own grid with the help of this device, of the EPS this device. What is important, it's rather good to turn it on, EPS auto recovery. If there is a EPS overload, the inverter will hold and wait for a confirmation that we know that overload is not a short circuit. But we may also check this checkbox, and this unit will automatically try to re-engage EPS every, I believe, 10 seconds. So even after an overload, this unit will try to reset and provide power to end customer. Here you can see bypass relay. This is really this EPS. External as set here, so that we are connected to the EPS box and we are trusting this EPS box to switch the power in a correct way. But we may choose internal here and we will operate on internal EPS switch without any problems. What else? Oh yeah, as I've said, those minimum SOC, maximum SOC, and the minimum SOC on grid. Those are those settings for setting the proper charge levels for those batteries. But still, even if you try to break them, BMS will always stand and guard them, not to be abused too much. They can be abused because they are designed to, but the BMS will try to put as low strain for them as it could. And of course, you can change your work modes remotely, directly on the settings page. After pressing this green arrow, unit will reset, and will start to work accordingly to the chosen mode. Of course, you can see also many other options. Those options are for checking battery life, operation. That can be, we can do a factory reset or turn off, turn on this device. We may set reactive power, for example, to limit the voltage rise on AC side. We may do an active power limitation, frequency power limitation. Voltage parameters, of course, can be changed, but it not really not recommended by the producer, by the manufacturer. But in some cases, there is a strong concern. If the lines are very long from inverter to the client, the voltage drop on those lines may be compensated by giving a 2 volts, 3 volts of such a compensation for your device. So you may always trim this unit to your needs on site, really easy. Okay, let's talk about our main focus, because we are focused on technology and we are focused on quality. And here we have our quality management process. That's to show that we have management processes, that we are operating according to SOPs, to processes. We are doing or trying to do everything right according to standards and according to certificates, according to the current law, and generally what's happening on the market. But this is a standard process of converting raw materials into something useful, something that can be stocked. Second thing about the FoxESS quality, and I've encountered that myself, because after working a bit in FoxESS, I've opened my first inverter to check how it's built, what's happening inside, and I've noticed that there are too many capacitors, because in the company that I've worked last, they were missing. Well, that's not really a problem, because this omitting of a component will generally not change the inverter's work much, but it will put more strain on those components. And you may also know that those are electrolytic capacitors. The less strain they have, the better, because the end of their life is when they evaporate all of their electrolyte. Those capacitors may work according to warranty, may or may not. We have given those more capacitors just to be sure that this device will endure to the end of the warranty and more, because this maybe not this unit, but T-Series has been designed for 15 years. they are getting, I believe, 12 years of warranty in standard, but they are designed to endure more, to be more capable, and of course less prone to damage or prone to some faults, errors, and so on. So such, a few bucks more gave us up to 20% more life expectancy that we can get without even higher price. And this is really a fine idea. This is a vertical industrial integration chain. So you mine your own dirt, you take this dirt with your own trucks to your own foundry, you process that dirt into lithium, cadmium, the whole range of metals and the rest. Then, after checking the quality of that material, you put it to manufacturing process to produce batteries or battery cases or inverters. The rest, you put your own product into your own chassis, close it, and this is a 100% yours. You have looked at it, measured it, checked the quality of it from being dirt to being a nice, very useful device on the market. So yeah, our quality and that we developed our batteries ourselves allows us to sell them in a really nice price, to be modular, because we can add or take from this system. We may integrate every safety and security measure that is really important into it, and we are sure that it will work. And we can then guarantee a 10 years of work without any problems, or 6,000 cycles with 90% of depth of discharge. So yeah, those batteries only needed the last item on the list. So the BMS. The BMS is also a very efficient and refined design. Right now, we are providing BMSs in the 2.0 version. Those are fourth version of BMS that have been tested and researched, developed, and then implemented into our stack, our devices. Batteries are manufactured without any human interaction. Those places are highly automated plants, and robots take all the work. They are welding with the help of a laser beam. The terminal are being laser welded. They are being stacked by automatic plants and robots. So yeah, we limit the possibility of human error to, and every our device goes through a very boring testing process. It is tested firstly as a simple sole boards and components, electronic components, that is done by automated optical inspections. Then there is a safety test, high voltage tests, environmental testing. Again, they are being checked if they are really hermetically sealed, and if yeah, the device is then packed. So it only leaves the plant, the manufacturing plant, after those 8 tests. So we really are focused to provide the highest quality. That is what we do. And the most important, I believe, thing for the installers, the end customers alike, is after sales. Because you buy your device once, and if you have some simple configuration problems during this device operation, you will not be pleased by this device. And if you have to wait for your support to do something or to call you, you have to wait, I don't know, 2 or 3 days, like I've seen other brands, not anyone particular. Yeah, that may be very negatively by the client. So, giving our high quality product, we wanted to get also a high quality management of our devices, after sales of our devices, and technical support for our installers and customers alike. It's better for end customer to call his own installer, but sometimes this installer is not able to get the call, so the client may contact us. We also can access those devices that are connected to the internet, and via a hotline or via our mailbox, he may contact us, check what's happening with the device, change settings, etc., etc. We have also, as you can see, training support. We do trainings for our installers. Sometimes also end users want to participate in such trainings for to know how to operate their devices better. So we have a team of trainers in Polish, English, to provide the needed knowledge, because the knowledge is the key that open up the door. So yeah, we want to give as much knowledge as we could, because this makes installers more confident, then the end client will be more pleased by the installer work, and then everyone will be happy and peace will rule the world, because end customer will have a good good quality equipment provided by knowledgeable people, and we have developed and given that device, so we are also really happy to. This is our main goal. I think we are doing our best, and yeah, we are doing that good. So both end clients and installers see this after sales as probably the most important thing for them, because they can always contact us, always send us an email. We send our answers right back. Our service team, our physical service team, uses our mailbox as a contact point. The client may send his claim at the mailbox. We are receiving such a mail, starting the diagnostic procedures, and if the inverter is faulty or maybe it's looking suspicious, but it may be a fault, we are sending a shipment letter to a customer to take this inverter to our workshop, check it, provide solution and or repair, send it back. Or if we check and yeah, there was a fault that we cannot repair, because we are not repairing, not soldering boards, nothing like that. If the main power board is damaged, the whole unit is being replaced. It's a high power device. We have to be sure that it's hermetically sealed, that it will work those 12, 10, 15 years on the client side. So if there is, I don't know, a capacitor burned on the main board, well, okay, those components may be reused, but this inverter is dead. For us, it's better to exchange that device and utilize this board as a dead one. So we don't really do such a deep repairing. We are rather checking, rather servicing. We can, but we want to be sure that the device will be as good as a factory one or better. Still, our R&D team is working around the clock. It's always accessible also for us. So if we come with some different, difficult sites that have to have some, I don't know, specific settings, our R&D department is always ready to guide us, to provide knowledge about our equipment and how to do some more complicated things. We are always a real-time connection with the manufacturer, like I said, for better look back and giving information about those devices and services right back to the manufacturer. The device is being replaced firstly after it has been shipped to us, and my colleague will state that yeah, we have to replace that. This replacement is usually done within 24 hours. So concerning the courier, it's a max 72 hours without the device for the end customer, usually. Uh, we try to act as fast as we can because again, it's best to be fast. If the inverter is replaced, of course the warranty is being transferred to the new device. As a company, we are insured that for any case, if we were to, I don't know why, but if we were to disappear or close the company, you will still have insurance. You will still have after sales. You will still have our services and our engineers help in whatever your endeavor is. This insurance insures well the general company, and it's a really good thing. It's another thing showing that we won't be out of the market. We won't disappear in the near future. We are here to stay. Okay, I will boast with with our headquarters now. This is our headquarters. It's generally REPT, so our battery research division. Those two buildings are Thingshan HQ. As I've said, the largest steel manufacturer producer in the world. We have our own operated and owned airport. So yeah, if you're going to China to check our factories, you will be probably greeted on our airport. Here we have some sport complex near our factories. This is the place I get my toys from. So it's our inverter workshop producing our devices, and this is our R&D center where all the big brains come to think and design better things and better devices. Thank you very much for your attention. I hope that I haven't bored you to death. If you have any questions, feel free. I think
yes. So maybe I will speak for a moment. It's a good thing that you showed the headquarters because we have how do you say it? You have a chance to win a trip to China. There's an option that there are actually two double tickets to win. The first one is for the person who from March to end of September buy the most of FoxESS products. During this time, one person, let's say, gets 2 tickets, and another one is if you buy FoxESS at Menlo, you will after buying, you will receive a thank you note in which you will have the link to answer 2 questions. our company will choose the best answers, the most original or most creative answers to these questions, and the person who answered the best will get the second double tickets to China. So to the headquarters of FoxESS, as you saw in the previous pictures. It's up to you to win them. So good luck. And I would like to show you also how you can easily buy FoxESS product through our web shop. Let me just share the screen.
I hope I will be able to greet you in China when you land. So yeah, feel free to participate in that event because it's a really fine deal. It's answering to questions, and you may also win a trip, I believe, of your life. It's
Uh,
pretty neat.
can you see maybe the screen that I'm sharing?
Yeah.
Yes, okay. So here, as you can see, that's the shop menlo.com. You can choose modules, inverters, accessories, etc. Here you have hybrid sets. If you choose FoxESS, that's what you have. You have 5 different kinds of inverters, which means the difference is, of course, the power of it. Here you have H3 with three modules and one BMS. So that's the whole set. You can buy that in one set. Okay, that's new. And you can that's the minimal number of modules that are needed to work with the inverter. If you want to add more batteries, you can of course choose batteries, FoxESS, and then you have Mira modules that you can add to cart as much as you want. Okay, so that's all for the web shop. I will write the link here in the comments. I wanted just to show you quick how you can proceed to how you can submit a ticket to our company, because we also have customer service as technical support. So here you can log onto this email. Do you see it or? Okay. Yes, that's the website. You have to log in. I am already logged, and the quickest way to submit a ticket, you just click on it. You choose the department that you want to talk with. For me, it's English technical support, but you have also customer service. You can put your phone number so we can reach you, the subject and the message that you want to share or ask. Here you can add, of course, attach a file and just send it, and it will land into our system. So as long as the ticket isn't answered, it will pop up as a task to do for us. So there's no way we will forget about it. Let's say. So yes. Okay, that's all for the Menlo part.